Okay, random variable x with possibilities. Okay, so yeah, we saw that. Okay, 2 of course is going to be, I know, 2 co, as we said, 2 co entropy is going to be lower, I know, because it's more predictable, I know. Okay, second, yeah. But if you see, okay, so it's very easy to calculate, right? Calculate that. It's easy, right? So of course, again, h of your h of x is going to be minus, I know, the probability of a, direct a, see, probability of x being a, probability of a log 2 probability of a, takes it, plus what's the next one? Understand? What's the next one? What's the next term?
Probability of B.
Yeah, log 2
Log 2.
and probability of b, right?
B.
Very simple, right? And likewise, you say h dot dot dot, okay? So when we say hamle ke garnu cha bhanदाखेरि सुरुमा हाम्रो के भयो फर्स्ट लेट्स राइट फ्यु टर्म्स जस्तै यसमै हेरौँ है सो सबैलाई किनभने यो माइनसले सबैलाई मल्टिप्लाई गरेको हुने सबै माइनस छ हेर्नुस् है सबै माइनस छ यो त भइहाल्यो हैन सो सबै माइनस किन छ भन्दाखेरि द होल थिङ all the terms are multiplied by minus हैन अनि फर्स्ट वान के भयो भन्दाखेरि what is probability of a? Probability of a half छ, you can see here, हैन अनि यो यहाँ गयो हैन what is the probability of b? 1/4 छ हैन यही नै यहाँ जान्छ हैन probability of c हैन and probability of c यही नै जान्छ and so on है अब यो गर्दाखेरि चाहिँ now bits कति आयो 2 बिटमा आयो हेर्नुस् त है we got 2 bits means now you can send the same information right with 2 bits for each letter है भनेपछि हरेक लेटरमा हामीले 1 बिट बचायौं भनेपछि अब मिलियन वटा लेटर पठाउँछ भने त we save a lot हैन हाम्रो ट्रान्समिसनमा we save a lot. Okay, all right, so that is the whole idea. So this, this idea, the Cloud Shannon information theory, it revolutionized the the communication, communications in industry. It really is landmark the discovery theory. Okay, all right, so basically, yeah. Let's see. Hey, so far, I hope guys are clear. Eh? Okay. So how about joint entropy? So I think we did that, in the last term because it's kind of hard. I know. I repeated. Hey. Okay. So how about so far we have been discussing only one random variable. Hey. So in real life, you have more than one variable interacting, right? More than one variable. Just say, let's see, so so let's see, now we have two variables. Okay, now we have only one variable here. Obviously, I'm two variable case right? Case variable, you're saying cloud, cloud variable. Cloud is one variable, presence absence of cloud, and rain or variable. Random variables. Random variable is the variable which can take on random values. This time random variable. Okay, so now we have two random variables. One is rain, another is cloud. So let's see the observations. We observe and just experiment or data collection. And after that, after data collection, data. So this is what we find. The table. So जस्तै हामीले 100 days को रेकर्ड गर्यौं है 100 दिनको रेकर्ड गर्यौं त्यसमा चाहिँ सो 24 out of 100 चाहिँ के छ रेनिङ र क्लाउडी हैन रेन र क्लाउड है रेन पनि भयो क्लाउड पनि भयो रेन पनि भयो है त्यसमध्ये ओके एक दिन चाहिँ के भयो एक दिन चाहिँ क्लाउडी थिएन त्यै पनि रेन भयो सि हैन अनि अब यो तलको हेरौं यसको मतलब के भयो ल यु गाइस टेल मी ल कैन यु इन्टरप्रेट दैट वन जस्ट यो चाहिँ यसलाई इन्टरप्रेट गर्नुस् त
क्लाउडी हुँदा नि रेन गरेन
एक्ज्याक्टली हैन 25 दिन चाहिँ के त्यो हाम्रो डेटामा 100 दिनको डेटा छ त्यसमा 25 दिन चाहिँ के भयो भन्दाखेरि इट वाज क्लाउडी बट इट डिडन्ट रेन राइट अनि 50 दिन चाहिँ के भयो भन्दाखेरि इट वाजन्ट क्लाउडी एन्ड इट डिडन्ट रेन है ओके अब यस्तो केसमा अब रेन र क्लाउडको जोइन्ट एन्ट्रोपी है जोइन्ट एन्ट्रोपी निकालौं है त ओके So how do you find the joint entropy? And it's the same, exact same one. Hey, now we have two summations here. So summation x over capital X and y over x, small x value and yo variable. Hey, okay, x capital X variable, x value. Okay, okay. So so the same. I formalize the same. Okay, let's try to do that here. H of rain or cloud, rain comma cloud. Hey, your joint, let's say joint function and a joint entropy. A joint entropy is equal to minus again. Right? Okay. So I'm looking on a probability of rain or cloud. The way rain or cloud. Probably rain or cloud. Any log 2 probability of rain or cloud. R and C, rain or cloud. Plus any next term, okay, it's our term also. Probability of rain and not cloud. Rain and not cloud like so. This C bar is fine. Right? C bar log 2 probability of rain, no cloud. Anila, you guys tell me the third term. A third term, Mr. Probability of
Not rain.
Not rain in cloud. Not rain in cloud.
Not rain, cloud. Very good. And log 2. Again, yes. Not rain and cloud. Plus, okay, give me the last term. Probability of
Not rain, not cloud.
yeah, not rain and not cloud. And log 2. And not rain and not cloud. See? Right? Now we know all of these. Suppose your table may say, so okay, what is this? What is your probability? So what is the probability? What is this one? Your probability of
Rain and cloud.
Rain and cloud. Very good. Rain or cloud. Okay. This thing you think you understand. This one. Probability of
Not rain, not cloud.
not rain, not cloud. Very good. See, and you just plug in the numbers and you see that you get 1.56 bits. Okay, so this is the joint. Just making. Now we have two variables interacting. Interacting variable. Right? So likewise, you can have 3 variables, 4 variables. How many more variables? Right? Okay. So basically, the formula is very straightforward, very easy. Right? And then application, the formula apply on make them simple. Right? Okay. All right. Okay, so now let's move on. Okay. Okay, well, let's talk about answers. So far we talked because we talked about entropy, right? At length with mathematical detail because so when you are trying to find the best predictor, best attribute, right? So what do we see? Which attribute is best, for prediction, right? This we need to find entropy, right? Okay, so that is the point because entropy cover okay, because our main aim saying Ensemble Learning, right? It's the add booster, okay. So let's see Ensemble Learning. I think we have discussed this a lot of times before, right? So of course it combines many classifiers, right? Different many classifiers, right? And then combining distant spelling a different classifier and simple voting can improve individual. See, individually Afima, they're not good, right? But when you combine them, okay, they tend to produce good result, right? Okay, and single algorithm may classify objects poorly, as you saw. Say random forest queue and decision tree. If you have full decision tree, okay, they quickly overfit, right? That was the problem. But when you combine them and make an ensemble, right, the overfit tends to be reduced, right? Okay, and finding simple relatively accurate. Okay, so normally of course simple relatively accurate classifier is often not hard. Okay, all right. So let's see. Okay, so there are two kinds of ensemble learning as we discussed before. One is the bagging, And then now this boosting, right? We have, I think I've emphasized this a lot of times. Say bagging ma ke huncha, you don't care. Tapaiko sequence, right? So because in both cases, we have many classes. It's an ensemble, means a collection, right? Collection of decision trees, right? So it's a collection of decision trees. And when we are creating those decision trees, right? We don't, as I said, bagging so we don't care, right? Which is created first, right? Just you can build them in parallel. Say if I have 100 decision trees or something, एकैचोटि बनाएर ब्यागमा फाल्दिने है हाम्रो ब्याग त्यो मर्निङमा है okay, that is parallel है बुस्टिङमा के भयो है लास्ट टाइम जुन I showed you with a video, right? त्यसमा देख्नुहुन्छ नि हैन first we create one stump है अनि त्यसले कस्तो क्लासिफिकेसन गर्छ हैन त्यसको आधारमा you pick another stump है and another stump त्यसरी हैन okay, so there is a sequence of process there. Okay, so bagging is okay, is parallel. Okay, and basically it doesn't care, hey, it doesn't really care. Hey, boosting ma it matters. Okay, किन भन्दाखेरि एउटा जुन डिसिजन ट्रीले गरेको मिस्टेक्सको आधारमा त्यसलाई फोकस गर्न है अर्को डिसिजन ट्री हामी बनाउँछ नि त है okay. All right, so let's see. Okay, bagging, also known as bootstrap aggregation, introduced by Leo Bryman, 94. Sampling is done with replacement. Okay, sampling, basically what you do is when you sample lead you take, you know, like 80% sample or 70% sample, right? And then every time you're replacing, right? So you're just grabbing a new set of, you know, that random points or random data, right? Whole distribution, right? If you have say 5 classifiers or distant trees, when hardly train gun so say 80%, right? 80% to whole distribution, whole data, randomly 80% sample choose every time, right? Different samples, okay? And train different models on a set of samples. Yeah, given a test point, it is predicted using all the models. See, every distant tree, after prediction, majority voting, right? Or either voting or averaging, right? The majority of prediction is taken as the actual prediction by combining all the predictions. Okay. All right. So also known. Okay. So I think this is just a repetition. Right? Okay. Sampling with this combining. Yeah. Okay. So okay. So of course it reduces variance. Right? Variance when you go, it's another word. Variance is another word for overfitting. Right? Variance. Right? Bias when you underfit. Right? There are two terms. Right? Normally you hear this in machine learning literature. You hear variance in bias. So bias is underfit. Right? Means your model is not capable of fitting your data. A model say comes away, right? Model strong by power bias. So model body complex by data right? If your model is too complex, it overfits, and that is called variance. Right? So high variance when variance when it's just a fancy word, okay? Right? Variance is just overfit. Variance should, okay? Machine learning, when we talk about variance, it's statistical variance, right? You see, machine learning variance. Machine learning variance becomes overfit. Variance when overfit. Okay, so bagging, you can see here, we create bootstrap samples, means K bootstrap samples. Bootstrap samples when it gets to D1, D2, D3, DK. Right? When you see every time you're picking some percentage of the sample. Right? Okay, the sample data. Let me quickly show you. Right? Let me see how much time we got. Yeah, we got time. Just there. So if I have this data, just the most of it is the data. So let's say 1, 2, 3, 4, 5, 8. For simplicity, I'll pick very little, fewer points. Right? Right? And data is to solve, right? Let's say given to now you using samples manually. Let's say D1, D2, D3. My 3 samples. Right? And let's see if I can number them. Numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Your points are right. So say मेरो first sample D1 right? D1 मा के आउन सक्छ randomly sample गर्ने नि त हैन यसो टोटलमा कति भनौँ ल let's say 12 वटा छ 12 वटा पोइन्ट छ भने I can take 80% है 80% about 10 हैन मैले 10 वटा लिन्छु randomly लिन्छु है randomly 1 आउन सक्छ हैन 6 आउन सक्छ 5 आउन सक्छ 10 आउन सक्छ हैन ओके अनि अर्को D2 यहीबाट यसैबाट है अब D2 निकाल्नु पर्यो भने I'll get 80% फेरि 10 वटा स्याम्पल लिन्छु 12 वटा मध्ये 10 वटा लिन्छु हैन but I'll have different numbers है okay different points are okay when you say all the D1 D2 they are coming from the same distribution hey they are coming from the same distribution but are they the same data एउटै data हो त त्यो okay
Why not?
why not yeah they are randomly sampled random samples right so अब के हुन्छ भन्दाखेरि now once we create these samples right bootstrap samples D1 through DK अनि हरेकलाई चाहिँ हामीले त्यही D जस्तै त्यो डेटामा ट्रेन गरिन्छ के means जस्तै हामीसँग distant tree 1 छ distant tree 2 छ distant tree 3 छ है so let's say DT1 छ DT2 छ हैन distant tree अब तीनटा distant tree हाम्रो ensemble मा तीनटा छ भने चाहिँ अघि हामीले जुन क्रिएट गर्यौं के छ तीनटा छ नि त है data D1 D2 D3 तीनटा डेटा छ नि which are different but they are coming from the same distribution है अनि के गरिन्छ भन्दाखेरि correspondingly हैन D1 ले DT1 लाई ट्रेन गर्छ D2 ले DT2 लाई ट्रेन गर्छ D3 ले DT3 लाई ट्रेन गर्छ है कुरा बुझ्नु भयो ओके अनि ट्रेनिङ भइसकेपछि नाउ यो चाहिँ एउटा के हो आइदर ब्याक अर बुस्ट हैन ensemble यो चाहिँ के हो ensemble हो है अनि यसको अब यसलाई प्रेडिक्सन गराउँदाखेरि यो तीनटा मध्ये जुनले यो हो भनेर भन्छ नि है जुन क्लास यो हो भनेर भन्छ अनि भोटिङको आधारमा हामीले चाहिँ त्यो मोडलको प्रेडिक्सन लिन्छौँ है ओके alright so let me clear this say classify new instance by majority vote either majority vote or average say normally majority vote बाट हुन्छ है okay alright so I hope it is clear के questions छ यहाँसम्म are you guys following so far ठीक छ
Yes, sir.
yeah okay. yeah okay so it's the same thing but depicted in a in a visual format right? So see हेर्नुस् त मैले अघि जुन भने एक्ज्याक्टली त्यही नै हो सेम कुरा है हेर्नुस् त so this is our training data हैन training data हाम्रो total data छ नि so this is our original training data है okay अनि त्यसलाई हामी के गर्छौं स्याम्पलिङ चाहिँ D1 D2 D3 DT -1 DT हैन so हामीले के गर्छौं त्यसलाई चाहिँ स्याम्पलिङ है मेबी 70% 80% whatever है स्याम्पलिङ गर्छौं all of them are different but they are all coming from the same data है same distribution हुन्छ है अनि के छ हाम्रो classifier है T classifier T वटा classifier छ C1 C2 C3 CT -1 CT हैन dot okay अनि हरेकले के गर्छ corresponding D1 ले C1 लाई C1 भने यो distant trees classifier हो के है D2 ले यसलाई क्लासिफाई गर्छ यसले हैन I mean ट्रेन गर्छ है अनि के भयो यो सबै कम्बाइन गरेर एउटा है C star है यो सबै कम्बाइन यो त ensemble हो नि त है यो ensemble क्रिएट बाट एउटा क्लासिफायर बन्यो अनि यो यसले कसरी प्रेडिक्सन गर्छ के को आधारमा प्रेडिक्सन गर्छ भन्नुस् त के को आधारमा प्रेडिक्सन भन्दाखेरि मेजोरिटी भोट हैन मेजोरिटी भोटको आधारमा जस्तै मेजोरिटी भोट भनेको चाहिँ सो फर एक्जाम्पल अब यो ट्रेनिङ भइसक्यो हैन ट्रेनिङ भइसकेपछि अब ट्रेनिङ भएपछि अब यो चाहिँ चाहिएन यु डोन्ट नीड दैट है ट्रेनिङ भइसकेपछि तपाईको मोडल सो दिस इज योर मोडल ट्रेनिङ भइसकेपछि यो हो नि त मोडल त ट्रेनिङ भइसकेपछि नाउ अब क्याट कि डग भनेर छुट्याउनु पर्यो फर एक्जाम्पल अथवा हैन क्याट कि डग भनेर सो अब यसले डग भन्यो हैन यसले डग भन्यो यसले पनि डग भन्यो यसले क्याट भन्यो है यो केसमा के भयो भन्दाखेरि नाउ प्रेडिक्सन विल बी डग किनभने मेजोरिटी भोट मेजोरिटी हैन के भयो भन्दाखेरि डग बढी आयो okay alright so let me claim this okay over random forest I think we talked about this before it's a bagging technique right random forest is a bagging technique You select samples of rows and columns and train distant tree with it. Replace and resample to train another distant tree. Yeah. Repeat it till we get sufficient model and test is a consider measure report. So basically random forest bagging or a bagging technique. A complete disambling random forest add a boost with boosting my kids random forest uses full distant tree. Right? A rig distant tree is a full tree. Right? Boosting my kids add a boost, especially add a boost my stopper users. Okay. Okay, so a complete distant tree with full trains that leads to overfitting. So this was the problem. Distant tree would work well. Any distant tree, decision trees, overfit huँदैन हामीले forest चाहिँदैन थियो कि है distant tree ले नै हैन distant tree को main problem के भन्दाखेरि it overfits quickly, very quickly, right? And then it means low bias and high variance. Hey, high variance means what is variance? I told you. What is variance? What is another name for variance?
Overfit.
I know, yeah, variance means overfit. Right? High variance means high overfit. Right? Okay, so less training error, but high test error. So of course, right? So again, right? So I think we have emphasized this many times. Overfitting ko symbol kyo, symptom kyo. And when do you know that your model is overfitted? कसलाई याद छ भन्नुस् त
ट्रेनमा चाहिँ राम्रो
ट्रेनिङमा राम्रो त्यसमा
high training score, low prediction score.
Yeah, very good, yes. है ट्रेनिङ स्कोर हाई हुन्छ भने ट्रेनिङ स्कोर भनेको तपाईले ट्रेन गर्नुभयो हैन ट्रेन गरिसकेपछि त्यही ट्रेनिङ डेटामा तपाई टेस्ट गर्नुभयो त्यसले दैट इज कल्ड ट्रेनिङ स्कोर है ट्रेनिङ स्कोर भनेको ट्रेनिङ गरिसकेपछि त्यही ट्रेनिङ डेटामै फेरि टेस्ट गर्ने दैट इज व्हाट the के हो that is training score. Hey, okay. भनेपछि दुईवटा score. Hey, so we're talking about two scores. एउटा चाहिँ sorry. Where is it? Yeah. Okay. So एउटा चाहिँ training score भने training score हो हैन अनि अर्को test score र validation score हैन okay दुईवटा कुरा हुन्छ हैन. So training score भनेको के हो? Can somebody tell me again what is training score? Training score भनेको के हो भन्नुस् त? Training score, yeah.
जुन डाटामा ट्रेन गर्यो त्यसैमा टेस्ट गर्दाखेरि ट्रेन
Yeah, J score आउँछ. Yes, very excellent. Thank you. Right. So जुन डेटामा ट्रेन गर्यो त्यसैमा टेस्ट गर्दाखेरि जुन स्कोर आउँछ, जुन accuracy whatever, है त्यो आउँछ. That is training score. And test score भनेको test data जुन कि it hasn't seen, the model hasn't seen, है ट्रेनिङमा हामीले दिएको छैन त्यो है त्यसमा स्कोर गर्दाखेरि त्यो चाहिँ टेस्ट स्कोर हुन्छ. र ओभरफिट को सिम्पटम के भन्दाखेरि यो ट्रेनिङ स्कोर इज हाई एन्ड टेस्ट स्कोर इज लो. त्यो भनेको के भन्छ भन्दाखेरि हाई भेरिएन्स भयो है अथवा ओभरफिट भयो है. ओके हाई भेरिएन्स or overfit, right? That's overfit. Okay. All right. So multiple models of dysentery leads to low variance. How do we take यो जुन high variance को problem छ, high variance problem के को problem हो भन्दाखेरि dysentery, individual dysentery को हैन. अनि how can we take care of that? त्यो
random forest.
Yeah, I mean not just random forest but ensemble. Right? Ensemble गरेर. Random forest is an example, yeah. Right? So by ensembling, right? Ensemble अथवा collection, using many of those as one unit, right? So ensemble गर्यो भने के हुन्छ भन्दाखेरि that tends to reduce the overfit. Okay. All right. So let me compare this. So here, of course, so we have 3 trees, right? 1, tree 1, tree 2, tree 3. तीनवटा trees छ हैन यो तीनटा tree बाट now it is you as a whole के भयो forest भयो, right? So you say B is the input, right? B is the input, C is the class. Hey, B is the input, C is the class. So you basically के हुन्छ भन्दाखेरि it's a probability of a class given the input. Hey, probability of class given an input. You only given. Hey, you bar any that is given. है यो चाहिँ प्रोबेबिलिटीको भाषामा हामी यसलाई गिभन भन्छौँ है ओके alright so let's see boosting right complete decision tree with full training data set these two we have said this many times and it means low bias and we have already talked okay so yeah multiple model decision tree leads to low variance we talked about this and then we can combine many weak learners means to say especially boosting like you mentioned boost full tree छैन नि हैन boost मा full tree छैन boost मा हामी के गर्छौं सिधै के गर्छौं भन्दाखेरि हरेक एट्रिब्युट लिन्छौं एट्रिब्युटबाट अनि डाइरेक्ट त्यो त्यसको के छ भन्दाखेरि त्यसको आउटपुट y मा जान्छौं है डाइरेक्ट एट्रिब्युट टु y म्यापिङ छ नि त एट्रिब्युट टु y है डिसिजन ट्री मा के हुन्छ मल्टिपल लेभल्सहरु हुन सक्छ त्यसमा हैन मल्टिपल लेभल्सहरु त्यसले गर्दाखेरि इट्स मोर पावरफुल है ब्यागिङ को केसमा हरेक डिसिजन ट्री इज अ फुल ट्री है फुल ट्री भनेको हुनाले they are pretty much they are strong right they are relatively they are strong right किनभने हरेक डिसिजन ट्री जुन random forest केसमा है random forest अथवा ब्यागिङ को केसमा but boosting मा के हुन्छ भन्दाखेरि we're taking stumps है stumps भनेपछि के भन्दाखेरि they are weak right because we're taking one attribute at a time अथवा one feature at a time है so त्यसले गर्दाखेरि they are weak learners means अब your y जुन y छ अथवा लेभल छ normally it's a complex interplay अथवा it's so जस्तै हामीसँग चारवटा फिचर छ भने है pretty much हैन दुईवटा अथवा तीनवटा अथवा चारवटामै त्यो भ्यालु डिपेन्ड गर्न सक्छ नि त है so but you are taking only one है त्यसले गर्दाखेरि you cannot do justice with that one है एउटाबाट मात्रै तपाईले you're trying to predict the output with just one variable at a time or one feature at a time right and then त्यसको पावरै पुग्दैन नि त of course हैन so that's why they are weak right they are weak learners right weak classifier weak learners right so but when we combine many weak learners right then we can create strong learners right weak learner यो केसमा के भयो यो हेर्नुस् है so the difference के भयो random forest मा के भयो weak learners छैन है pretty much relatively they are strong each decision tree is very strong है problem त्यसमा के थियो overfitting को problem because they are strong overfit कहिले आउँछ भन्दा तपाईको मोडल कम्प्लेक्स भयो है ओके सो भनेपछि त्यहाँ चाहिँ प्रब्लम के छ ब्यागिङमा प्रब्लम के हो डिसिजन ट्रीको भन्दाखेरि दे ओभरफिट तर बुस्टिङमा के छ भन्दाखेरि दे आर वीक है किनभने दे आर स्ट्रङ and then if we combine these many weak learners then you can form a strong learner है okay जस्तै धेरै त्यो जस्तै सिन्का हुन्छ नि हैन आफैमा के छ they are weak right but if you combine then यत्रो मोटो बनायो भने it's very hard to break हैन so it's something like that right okay all right so now let's talk about strong classifier for complex decision boundaries so now these like boosting techniques and they work well with this kind of this decision boundaries decision boundaries are more complex see complex like circular classifier ले पनि गर्न मिल्दैन linear classifier गर्ने कुरै भएन हैन so these are यस्तो खालकोमा है then like this kind of like boosting techniques work well right okay so I think we've seen this before right so each one see now we have three trees right three trees and then of course all three are weak learners right weak learners and then see each classifier is trained on random subset of data samples right so अनि त्यसपछि of course हामी boosting मा के गर्छौं भन्दाखेरि of course what we do is data samples which are difficult to classify are selected for training see as you saw in the last time I mean data boost मा गर्दाखेरि we saw that हामीले अर्को data set create गरेका थियौं जसमा के misclassified data हरु के थियो multiple times आइरहेको थियो नि है त्यसले गर्दा के हुन्छ भन्दाखेरि so they get more focus उनीहरुको weight पनि बढ्छ sample weight हैन means they get more focus and the classifier focuses more on those data that have been misclassified by the previous learner a previous classifier right okay all right so now how do you make them strong of course you combine them right combination of weak classifiers is expected to improve the accuracy, okay, under certain conditions, right? So, okay. So these are some of the mathematical formulas, right? Okay, so AdaBoost is an algorithm for constructing strong classifiers, linear combinations. See? So every one is the HDFX, right? So SDFX schizophrenia, these are individually, these are weak learners, right? Let me try to unravel this for you. Say now, for example, we have 3 classifiers. So many alpha 1, right? H1 of x plus alpha 2, S2 of x plus alpha 3, S3 of x. Right? Theta. H1 classifier, you see, to stump 0. Right? Stump 1, stump 2, stump 3. Right? And this could part. Right? So alpha is you're using given the alpha, let's see. Right? Let's go. So you can control this. Right? Basically, amount of C. Last time we talked about that, right? Amount of C. Okay, let's say amount of C. Okay, so alpha are the amount of C. Right? अब यो सबैलाई combine यो भनेको sum हो है यो sum गरेपछि के भयो combination आयो नि त sum भनेको plus यहाँ सबै हामी plus गरिरहेको छौँ नि so that is the sum. Okay, all right, so let me clear this. Okay, all right, so let's see. अब यसमा see here. Okay, g of x, so weighted sample. See, here saying these are the data. So data case data so you have training sample. You have to think about training sample by training sample by weighted sample. Right? Weighted sample. See, if you remember from last time, original data data set using relate rule technique. I'm not sure. Okay, I'm sure that you still remember. Relate rule technique randomly just go weight body theory. Right? This मध्ये हामीले resample गर्दाखेरि sample weight resample गर्दाखेरि so those examples or those samples right, that were misclassified by the previous term had greater weights. Misclassified rows है तिनीहरुको sample weight हामीले बढाएको थियौं है अनि त्यसलाई हामीले roulette wheel जुन algorithm use गर्दाखेरि अनि अर्को नयाँ data set बनाउँदाखेरि हामीले roulette wheel technique use गर्यौं अनि त्यसले चाहिँ it makes sure that के हुन्छ भन्दाखेरि त्यो जसको sample weight बढी छ नि तिनीहरु धेरै आउँछ है resample मा है. Okay, so exactly, see, misclassified examples, sorry, write it down here, misclassified examples get higher weights, right? And correct examples get lower weights. Get one, we actually do that, hey, the algorithm lane ke garchhau bhandakhari jun misclassified huncha त्यसको sample weight हामी scale up गर्छौं हैन र correctly classified examples लाई के गर्छौं भन्दाखेरि we down के रे त्यसलाई हामी downscale गर्छौं है okay downscale गर्छौं है okay अनि त्यसले गर्दा so we have different weighted samples. See, we have different weighted samples. Okay, so you might have to go back and watch that video. Okay? So let me see. Okay, initialization. Okay, so अस्ति जुन हामीले गर्यौं नि त्यसैको quick recap है यो चाहिँ it's the same thing that it's quick recap है. So okay, AdaBoost initialization meta learning algorithm with great theoretical and empirical performance. Yes, right? Turns a base learner, which is a weak learner, into high performance classifier. Creates an ensemble of weak hypotheses by repeatedly emphasizing mispredicted instances. See, now यसको boosting को एउटा के भन्दाखेरि boosting ले के गर्छ भन्दाखेरि see, this is the thing, right? Repeatedly emphasizing misprediction. भने जुन misclassified हैन misclassified जुन examples हरु छ उनीहरुलाई के गर्छ उनीहरुलाई फोकस गर्छ उनीहरुलाई emphasize गरेर अनि जुन next जुन stump on also. It tries to take care of that. Right? Take care of it. Okay. Okay, let's go on to the next one. Second, let me clear this first. All right, so our okay. Last time gigs, just a quick recap. Last time we did it through video. Point by point. Okay, so I'm let xi, yi, I goes from 1 to m, be the training data consistent of m samples. So m order samples also. X1, Y1, X2, Y2, X3, Y3, X4, Y4. There's the m sum. If you have m is 100, x100, y100 sum. Okay, so that means we have m training data samples. Right? Let each point one of the two classes, yes or no. Right? Okay, so it's a training data, XY training data, and each point is one of two classes. Right? Initially, each point is assigned a weight 1 over m. Right? 1 over m. Okay, so if you remember from last time, we have less than 1 minute. Right? So let's do this. Right? So okay, I'll end here. Right? Please join back. Join back on our line. Okay.
Okay, sir.